Are you ready to dive into the world of hypothesis testing? This video will guide you through developing and refining hypotheses, understanding null hypotheses, and their significance in research. By the end, you'll grasp the essentials of creating and testing hypotheses. Developing and refining hypotheses is a crucial aspect of scientific research. Start by identifying a specific research question or problem within your field of interest. Conduct a literature review to understand existing knowledge and identify gaps. Formulate a tentative hypothesis based on your research question and literature review. Make it a clear, testable statement proposing a relationship between variables or an expected outcome. Define and operationalize the variables in your hypothesis. Specify how you will measure or manipulate these variables during data collection. Consider alternative hypotheses or explanations for the phenomenon you're studying. This helps refine your hypothesis and consider different possibilities. Continuously refine and clarify your hypothesis to make it more specific and aligned with the research question. In some cases, conducting pilot studies or seeking expert input can help refine the hypothesis. Pilot studies ensure the validity of your hypothesis. They provide preliminary data and insights. Experts can offer valuable feedback and suggestions. This process enhances the robustness of your hypothesis. The null hypothesis, denoted as H0, is a fundamental component of hypothesis testing. It represents the default assumption that there is no significant effect, relationship, or difference between variables. The null hypothesis is designed to be testable. It provides a framework for assessing whether observed results are statistically significant. Researchers use statistical methods to determine if they can reject the null hypothesis in favor of an alternative hypothesis. The null hypothesis serves multiple purposes in research. It ensures hypotheses undergo rigorous testing and scrutiny. By assuming no effect, it establishes a baseline for comparison. This approach helps avoid premature conclusions. It serves as a basis for making inferences about populations based on sample data. The null hypothesis is designed to be testable using statistical methods. It allows researchers to assess the likelihood that observed results are due to random chance. This provides a controlled environment for hypothesis testing. It ensures conclusions are drawn based on empirical evidence. The null hypothesis facilitates objective assessment of research findings. Identifying a hypothesis involves recognizing a statement suggesting a relationship between variables. In medical research, a hypothesis might propose that a new drug reduces blood pressure in patients. In psychology, it could suggest sleep deprivation affects cognitive performance. These hypotheses are testable and propose specific outcomes. They guide empirical investigation. Formulating a hypothesis involves crafting a clear, testable statement. It expresses a proposed relationship between variables or an expected outcome. Start by identifying a specific research question within your field. Review existing literature to understand known aspects and gaps. Choose the variables involved in your research. Decide whether your hypothesis is directional or non-directional. A directional hypothesis predicts a specific direction of effect. A non-directional hypothesis predicts a relationship exists without specifying the direction. Write a clear statement articulating the expected relationship between variables. Ensure the hypothesis is testable and falsifiable. Use proper syntax for hypotheses, often including conditional words like if and then. For example, if students use interactive online tutorials, then their learning outcomes will improve. Ensure your hypothesis is clear and unambiguous. It should be easy for others to understand and test. Clarity is key in hypothesis formulation. Consider a research question in education. Does the use of interactive online tutorials improve student learning outcomes in mathematics? Formulate a directional hypothesis. If students use interactive online tutorials in mathematics, then their learning outcomes will improve compared to those who do not use these tutorials. This hypothesis is clear and testable. The null hypothesis is a fundamental component of hypothesis testing in research. It serves specific purposes and is formulated to provide a point of reference for statistical analysis. The primary purpose is to establish a baseline assumption of no effect, relationship, or difference. This ensures conclusions are drawn based on empirical evidence rather than preconceived notions. The null hypothesis provides a basis for comparison with the alternative hypothesis. Researchers analyze data to determine if there is sufficient evidence to reject the null hypothesis. This facilitates objective assessment of research findings. The null hypothesis is designed to be testable using statistical methods. It allows researchers to assess the likelihood of observed results due to random chance. The null hypothesis is typically formulated as a statement of no effect, relationship, or difference. Its structure varies depending on the research question and study nature. Common forms include equality, no relationship, no effect, equality of means, and no change. It represents the default position that researchers aim to evaluate through statistical testing. Null hypotheses often express no significant difference or effect. For example, there is no significant difference in test scores between Group A and Group B. In cases involving correlations, it might state, there is no significant correlation between hours of study and exam performance. These hypotheses guide empirical testing and analysis. When examining interventions, a null hypothesis might state, the new drug has no significant effect on blood pressure. In the context of means, it could be, the mean weight of product A is equal to the mean weight of product B. These statements provide a baseline for testing effects and differences. For experiments involving change over time, a null hypothesis might state, there is no significant change in plant growth over 1 month. This provides a reference point for assessing changes. Such hypotheses are crucial in longitudinal studies. They help determine if observed changes are due to interventions or natural variation. Testing these hypotheses informs conclusions. In conclusion, the null hypothesis plays a central role in hypothesis testing by serving as a benchmark for comparison. It assumes no effect, relationship, or difference between variables, ensuring that conclusions are drawn objectively from empirical evidence rather than assumptions. This structured approach allows researchers to minimize bias, maintain rigor, and validate their findings with confidence. Through understanding both hypothesis development and the function of the null hypothesis, you now know how to design, test, and interpret hypotheses effectively. Applying these principles not only strengthens the reliability of your research, but also contributes to meaningful insights across academic and professional fields. By mastering this process, you are better equipped to conduct research that is systematic, credible, and impactful. If you have any questions, please feel free to reach out via WhatsApp or email. Thank you.